Ladies and gentlemen, dear colleagues, dear guests, let me declare open a session of the Dissertation Council for the Defense of Thesis by Sedakov Artem Aleksandrovich for the degree of Doctor of Physics and Mathematics, Specialty 01009, Discrete Mathematics and Mathematical Cybernetics, on the theme Dynamic Network Games, by the order of St. Petersburg University, dated the 20th of May 2020, number 4465/1, May Gromova Ekaterina Viktorovna, Doctor of Physical and Mathematical Sciences, Professor of the Department of Mathematical Game Theory and Statistical Solutions of St. Petersburg University, was appointed Chairman of this Dissertation Council. Members of the Dissertation Council were appointed with the same order. Let me introduce them to you. We have here Mazalov Vladimir Viktorovich, Doctor of Physics and Mathematics, Professor, Director of the Institute of Applied Mathematical Research of the Karelian Scientific Center of the Russian Academy of Sciences. The remote access mode we have Malafeev Oleg Alexeyevich, Doctor of Physics and Mathematics, Professor of the Department of Modeling of Socio-Economic Systems of St. Petersburg University. Oleg Alexeyevich, can you see? Can you hear us? Oleg Alexeyevich, please say yes if you can hear us. I shall ask the question again in a couple of minutes. Let me introduce other members. Vasil Aleksandrovich, Doctor of Physics and Mathematics, Professor of the Department of Operations Research of Moscow State University, named Alexander Alexeyevich. Can you see? Can you hear us? Please switch the microphone on when answering. Please switch your microphone on. Can you hear us? Yes, I can see and hear you. Thank you. Avrachenkov Konstantin Evgenovich, PhD, National Institute for Research in Automation and Informatics, INRIA, France. Konstantin Evgenovich, can you see? Can you hear us? Yes, I can see and hear you well. Next, we have Garnaev Andrei Yurovich, Doctor of Physics and Mathematics of Rutgers University, United States of America. Can you see and hear us, Andrei Yurovich? Yes, I can see and hear you all as well. Li Denfen, PhD, University of Electronic Sciences and Technology of China. Can you see? Can you hear us? Yes. Also with us, we have the degree applicant Sedakov Artem Aleksandrovich. Also at this session, the academic advisor, the degree applicant Petrosyan Leon Ganesevich, Doctor of Physics and Mathematics, Professor at the Department of Mathematical Game Theory and Statistical Solutions of St. Petersburg University. Let me say again that to improve the quality of connection, Oleg Alexeyevich, Oleg Alexeyevich seems to be online, but we have sufficient number of members. Dear colleagues, to improve the communication, please turn off your microphones, but don't forget to turn them on when they're given the floor. Oleg Alexeyevich, I have to call a technical break for 5 minutes because the sound is on.
Звук включился. Алло.
Да, я вас слышу.
Алло. Алло.
Олег Алексеевич, мы вас не видим. Мы вас теперь слышим, но не видим. Вы отошли от камеры.
Меня? Я не отошел от камеры. Я в маленькой камере, в маленьком окошечке от себя вижу. У меня вроде все в порядке. Написано «Остановить видео». Я его не останавливаю. У меня маленькое окошечко есть, я в окошечке
А вот если вы сейчас...
вижу себя.
Да, вы себя видите. А мы вас не видим, мы только видим ваш стол. А вас там нет. Вы направьте на себя
Нет,
камеру.
что?
Сейчас, секунду, вам позвонит сотрудник.
Камеру вот направлена. Я себя вижу. Я двигаюсь. Все в динамике. Все в динамике. Алло. 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 Я-то вас слышу.
Сейчас, подождите, мы вам позвоним.
Да я слушаю.
Включайте камеру в то время, когда вы просто присутствуете и ничего не говорите. Что в противном случае будут остановки заседания у нас по техническим причинам. Да. Вот. Давайте продолжим, да? Еще раз повторю.
Let us continue. Please switch off your microphones, but keep your cameras switched on during the session. Let me remind you that our session is being recorded and broadcast online at St. Petersburg University website. The speeches are being simultaneously translated from Russian into English or from English into Russian. During the live broadcast of the Dissertation Council session, an email address is currently displayed at which all the listeners can send their opinions and questions to the applicant online regarding his thesis and the ongoing scientific discussion of his presentation. These questions shall be forwarded to me by the Technical Support Department. I shall read them during the discussion. Questions should be related to the applicant's presentation and the content of his thesis, and it's obligatory to indicate the name, position, and place of employment of the author of the question. Questions that are not related to the scientific discussion, to the discussion of the thesis, to the text and evaluation of the thesis should not be presented. Well, in accordance with the order of awarding at St. Petersburg University the degree of Candidate of Science and Doctor of Science, approved by the local regulations of St. Petersburg University, hereinafter referred to as the order, a session of the Distinction Council is considered competent if at least 2/3 of the approved composition of the council members are present, but not less than 4 persons. Our dissertation council consists of 7 members. Now 6 members are currently present, including 4 members of the council in the remote interactive mode. Audio-visual contact has been established with all the members of the dissertation council. Thus, we have the quorum. Very briefly, let me set forth the procedure of today's session with the approximate duration of 3 hours. We shall start with the chairman's summary report on the main content of documents submitted by the degree applicant and their compliance with the regulations. A brief presentation by the degree applicant outlining the key points of his study. Next, questions to the applicant strictly on his report from the council members and answers of the applicant, speeches of the members of the dissertation council with their assessment of the thesis and answers to remarks and questions of the applicant. Next, speech of the chairman and his review and answers of the applicant to not more than 5 minutes for all. That shall be followed by the open discussion, speeches of those present at the session with no more than 2 minutes for each speaker. At that, all the speakers are kindly requested to register in the registration sheet and to fully introduce themselves before speaking. Then we shall present questions, if any, sent online, and the academic advisor of the degree applicant, no more than 3 minutes. That will be followed by a discussion by members of the dissertation council, during which the sound shall be switched off. After that, we shall proceed to the open individual voting. The chairman shall count the votes, and the results shall be recorded in the minutes of the meeting. And then we shall decide to award or not award the degree, and that will be followed by closing remarks of the applicant. Now I see all the 5 members of the dissertation council working in the remote access mode. 7 out of 7 members. Do you have questions regarding the procedure? If you have no questions, let us proceed. Let us start the procedure. Well, chairman's summary report on documents submitted by the applicants Sedakov and Artem Aleksandrovich. The thesis by Sedakov for the degree of Doctor of Physics and Mathematics, Specialty 010109, Discrete Mathematics, Cybernetics, on the theme Dynamic Network Games, was accepted for defense by the Order of Academic Secretary of St. Petersburg on the 20th of May 2020, number 4464/1. Sedakov Artem Aleksandrovich wrote his thesis at St. Petersburg University under the guidance of Doctor of Physics and Mathematics, Professor of the Department of Mathematical Game Theory and Statistical Solutions of St. Petersburg University, Dean of the Faculty of Applied Mathematics, Controlled Processes, Petrosyan Leon Aganesovich. Number of publications which outline the main points of his research, according to the enclosed list, is 18. 5 publications in journals recommended by the list recommended by Minister of Science and Administration, and 13 publications in journal, index, scientometric databases, Web of Science, and Scopus. The degree applicant presented to the academic secretary a full set of documents to accept the thesis for consideration and defense. All the documents comply with Article 12 of the order. All the documents submitted by the applicant according to the information received from the curator comply with the requirements that are kept in the applicant's attestation file. Copies are available from the officer of the Decision Council Activity Support Department, who is currently present at the session. Before we give the floor to the degree applicant, all is well. Before I give the floor to the degree applicant, do council members have any questions, general questions to the degree applicant, and is it necessary to disclose and review the entire list of documents submitted by the degree applicant? I see there are no questions. Let us give the floor to the degree applicant for his report. Thank you. Dear members of the council, let me present to you my thesis on dynamic network games written at St. Petersburg University under the guidance of Professor Leon Aleksandrovich Petrosyan. Can you hear me? We can turn the sound on. Okay. Let me repeat that I want to introduce my thesis on dynamic network games written at St. Petersburg University under the guidance of Professor Leon Aleksandrovich Petrosyan. In the literature, network games are understood as conflict situations at which the structural relationships between participants in the conflict is described by a network set or formed of them simultaneously. Network games are often also understood as conflict situations in which there is an object set by the network, a state of which is reflected in the pace of the players. Well, the problem of distributing a pace of. The thesis presents the development of network game theory both in a non-cooperative setting, allowing for a class of dynamic games with discrete time. The main goals are as follows: construction of solutions in the considered class of dynamic network games for non-cooperative case Nash equilibrium and other solutions based on this concept, and for the cooperative case solutions of cooperative game theory such as the Shapley value, the core, etc. Development of mechanisms that motivate players to maintain cooperation throughout the considered period of development of the network game and make it impractical to review the cooperative decision at any time. To achieve this, the following tasks are solved in the thesis. First, in dynamic network games with discrete time, Nash equilibrium situation and the cooperative strategy profile are constructed. If perfect information is available in a dynamic network game, the situation of absolute Nash equilibrium of perfect subgame is constructed. In dynamic event trees, an adapted Nash equilibrium situation, the cooperative strategy profile are constructed. 2. The problem of determining the characteristic function of cooperative network game is solved and is found then to determine it in accordance with the approach of von Neumann-Morgenstern sufficient to solve the maximization problem. 3. The dynamically stable, strongly time consistent and position consistent cooperative solutions for dynamic network games are constructed. Sufficient conditions for strong using a linear transformation of the characteristic function that guarantees strong dynamic stability of the core. A convergent interactive process constructed and the properties are investigated. Based on these solutions, a mechanism for strategic support of cooperation in online games is provided. Using the developed theory of dynamic network games, a number of game models of practical significance have been investigated. I'll start with the simplest class of dynamic network games, a two-step. So we have a finite set of players who are involved in a two-step conflict. In the first step, players select players who are willing to connect with. This is done at the same time. Player I chooses a vector, Gi, whose components reflect his office, taking into account restrictions on both their number and the set of players to whom he can offer a link. Such actions in the first step lead to the formation of an indirected network at which links are established only between players who have offered each other links. In the second step, each player observing the implemented network can correct it by deleting a number of links and also select some control variables. Simultaneously, these actions in stage 2 lead to network a new network. It's assumed that the player's wins are set by a non-negative function that depends on his own actions and actions of his neighbors in the network. It's also assumed that these functions satisfy property C, where it motivates players to create more links. The player's strategy is a rule that prescribes an action for each step of the game and the network empty at the first stage, announcing links at the first step, then adjusting the network along with the choice of variables at the second. That way we can define the game in the normal form. Allowing for the possibility of coordinated choice of strategies, players implement a cooperative strategy, set of strategies that maximizes their wins, and then at the end of the game distribute this amount according to the division from pre-agreed cooperative solution. For this reason, a transition is made from a game in normal form to a game of characteristic function, NV1. Theorems 2.1, 2.3 in the thesis state that when property is fulfilled on player payoffs, the characteristic functions in V2 in the one-step subgame defined according to the classical approach of von Neumann and Morgenstern are solutions to maximization problems. In the implementation have the following form. Construction of a characteristic function, we can define the cooperative solution, the two-step network game, a rule that matches a subset of divisions and game of imputations. However, for the player's agreement to be implemented, the cooperative must meet the important be dynamically stable or strongly dynamically stable, time consistent. The property encourages players to adhere to cooperation agreement at any time and makes it impractical to review it. The fact of violation of time consistency was first noted by Dr. Peterson for the class of cooperative games. Later, together with Danilov, he proposed a way to overcome this problem using the imputation distribution procedure IDP, the scheme that distributes pays off of players in a situation. This slide shows a definition of imputation, the IDP, a dynamically and strongly dynamical stable division distribution procedure. I will give a number of results for the two-step network games, which are formulated in the thesis in theorems 2.4, 2.6, and result 2.1, 2.4. Point 1 defines the type of time-consistent IDP class of cooperative solutions of the two-step network games that are time consistent and strongly time consistent is established. These are points 2 and 3. The core is chosen as the solution, then the IDP that meets the conditions in point 4 will be strongly time consistent. The above results follow from the results obtained for cooperative dynamic games, a subclass of which are two-step network games. These are the results concerning the strong time consistency of the core presented in the thesis in theorems 1.1, 1.4. In particular, paragraph 6 sets out the conditions that IDP must meet for the imputation from the core in order for it to be strongly consistent. Further, using the transformation rule of the characteristic function proposed by Dr. Peterson, the process based on such transformation is constructed for non-negative player payoffs and their positive sum. In a cooperative situation, the convergence of this process is established at each step of the game. Theorem 112. The limiting characteristic function is found, result 1.5, and its properties have been studied. Thus, we established that the modified and limiting characteristic functions in a two-step network game and its one-step subgame coincide. Next, the results of the time consistency of the Shapley value, the core, and the strong time consistency of the core for the class of two-step network games with pairwise interaction. These are theorems 2.7, 2.9, results 2.5, 2.7 in the thesis. Superadded characteristic functions are constructed for the case of a network with directed connections, theorems 2.10 to 11, which allows us to use this theory for this type of network as well. Thus, the construction of a characteristic function in a two-step network game together with analysis makes it possible to combine the results obtained and extend them to the multi-step network games with the following types of player actions of this type. Announcing links in the first step and adjusting them in the second stage and choosing the control variables. I'll move on to multi-step online games with a shock. Here, a finite set of players and periods are set. As in the two-step network games, the initial step, the formation of network, subsequent adjustment, is assumed that before adjusting the network, a shock is possible, a random and one-time impact on the impact, which consists in removing all the links with a given player. The probability of a shock before the network adjustment is constant and equals P. If the shock occurs, other players can form a new network without this player, after which the shock no longer occurs. As before, players receive payoffs at every step, except for the network formation steps. The player payoffs depend on his actions and those of his neighbors. Theorem 215 of the thesis defines the structure of such strategies under the assumption players from one network do not change it till a shock occurs, and when it occurs they form another network and don't change it till the end of the game. An expression of a superadditive characteristic function of a network game with a shock using characteristic functions in one-step games. This is Theorems 216 and 218. This representation allows us to obtain the form of the shapely value in a game using shapely values in one-step games, Theorem 219, and an explicit form of a positionally consistent IDP, shapely value, Theorem 217. Should say that positional consistency of a cooperative solution is a generalization of the concept of dynamic stability for the case ambiguity, presence of random elements in the game. We have also analyzed the behavior of companions of shapely value and payoffs to players. Now let us move on to dynamic games with perfect information on tree graphs. Players form a network sequentially in a finite number of steps according to a given sequence of moves and have perfect information. At the time of decision, a player can establish a new link with one player or break an existing link with another player without requiring their consent or take no actions to change the network. The play defines the sequence of networks starting from the specified one. In each node of the game tree, the network and utility of players from links with others are set. The game is built on a tree graph. The functional equations in Theorem 4.1 of the thesis characterize the situation of absolute perfect Nash equilibrium in a multi-step game. These equations are shown on the slide. In addition, the thesis presents Theorem 4.2, which characterizes the equilibrium for a non-unique player actions that maximize a function at each step. Other approaches to dynamically forming a network according to a given sequence of moves and perfect information about the game, including is it necessary to get consent of both players to create a link between them. In the first model, each pair of players discuss creating a link between them according to a given order, the Ammann and Meyerson model. In the second model, players consistently offer links to any subset of players according to subsettings similar to the model shown in this slide. A player's payoff is determined by a single point solution to a game without, based on the graph of links between players. For example, the Meyerson value. For each model, a game is constructed in an expanded form of the tree graph, and the existence of absolute perfect Nash equilibrium is shown as results 4.1 and 2 in the thesis. Next, we explore cooperative multi-step games with interval pays-off and perfect information. Players' pays-off are set at closed intervals. The player's payoff function is shown on this slide. Cooperative strategy is a set of strategies that maximize the total median payoff of the players. The following results are obtained for this class of games. A superadditive characteristic function of a cooperative multi-step game with the interval payoff and perfect information and an analog of shapeless value have been constructed. Dynamically stable IDP is defined for the median element of the analog of the shapely value and the conditions that must be satisfied by dynamically stable IDP for its element are given. Let me proceed to the applications of dynamic network games. The first application is social networks. Here we consider the finite step game of opinion dynamics. Agents have their own opinions on a certain issue or initiative, and players can influence their opinions. The dynamics of opinions is given by the following linear equation shown in this slide, taking into account the degree of trust to each other and players for the given initial opinions of agents. The player's payoff is determined both by the average proximity of the agent's opinion to their desired opinion and by the influence costs they incur. Additionally, the proximity of the average opinion to the desired one is considered. Theorems 3.9 and 3.10 are characterized by cooperative strategy. It's constructed when considering classes of program and positional strategies, and then the problem distribution of total cost is solved. These results are formulated in Theorems 3.11, 3.13. As a consequence, the Nash equilibrium is found. The results are illustrated by examples of the Universitetskaya graph and a two-dimensional lattice graph. A comparison of the two types, a strong stable is proposed for the division from the core shapely value as a way to distribute the total costs of players in cooperation. Theorem 3.4.3.8. A number of economic applications we have considered. Cooperation, the model of providing public goods in the formation of a two-stage network game is studied. The model shows a positive effect of new links. Statements 2.1, 2.3 in the thesis define characteristic functions, and statement 2.4 shows the conditions under which these functions coincide, which makes time consistent. In the formation of two-step network game cooperation in the model of market competition, here we watch negative effect of new links, and consequently players form an empty network when cooperating. Statements 2.5, 2.6 in the thesis define the characteristic functions that coincide in this model, which means that any cooperative solution will be time consistent. The game with a major player is considered as a dynamic game with perfect information on the tree graph, the Myers-in value, average tree solution, and the Shapley and Myers-in values, statements 4.3, 4.5. Also, we studied interested in 4.3, 4.8. Finally, we studied cooperative and equilibrium behavior of harmful emissions in certain dynamic game on binary event tree. From theorems 5.1, 5.2 found Nash equilibrium, cooperative strategy profile, and corresponding player payoffs. Then we found explicit expressions for the price of anarchy, its lower and upper limits, and analyzed the sensitivity. In the thesis, this is theorem 5.3 and result 5.1. I will give the provisions submitted for the defense now. Formalization of a dynamic online game in which players are given the ability to form links with other players, correct already formed ones, and select additional control actions. Construction of a super-additive characteristic functions in a two-step network game, both in the case of an indirect and determine the conditions for time and strong time consistency of cooperative solutions, bringing their adaptation to two-step network games with pairwise interaction. Construction of a super-additive characteristic function on its basis, a positionally consistent imputation distribution procedure for class of dynamic network games with a shock. 4. Sufficient conditions for the strong time consistency of the core and procedure for IDP from the core for cooperative dynamic games. Convergence of the iterative transformation process of function which provides strong time consistency of both the IDP from the core and the IDP from the core constructed from the limiting characteristic functions. And 5. Finding the Nash equilibrium, characteristic function, and cooperative solution, Shapley value, in a network game of opinion dynamics with discrete time, determining the conditions of achieving consensus in the model of opinion in 6. Finding a situation of a perfect Nash equilibrium in dynamic network games with perfect information and player pays off based on Shapley value, which as a result allows using solutions such as Myers value, the average tree solution, and encouraging the centrality of values. Finding cooperative solutions in the game with the major player, and determining the conditions under which players are interested in creating links in dynamics. Construction of an analog of a Shapley value and finding conditions for the time consistency of its element. Perfect information played on tree graphs. Explicit expression of the price of anarchy as the rate as players' cooperative payoff. Low and upper bounds and their sensitivity analysis, and also managing the volume of harmful emissions described in a dynamic game on a binary event tree with homogeneous players. 26 papers were published on the theme of the thesis. The main results of the thesis were published in 18 papers in peer-reviewed scientific journals from the list approved by the Ministry of Education and products indexed in the Web of Science and Scopus databases, in particular mathematical game theory and its applications, management problems, applied mathematics and compilation, automation and remote dynamic games and applications, European Journal of Operational Research, International Game Theory Review, Journal of Intelligent and Fuzzy Systems, Mobile Networks and Applications. The following slide shows a list of 18 articles that outline the main scientific results of the thesis. The main results of the thesis were presented at international conferences and seminars on dynamic games and ISDG applications, international conference on network game nets, international seminars, network games and management, NGM, international conference, game theory and management, GTM, the 20th conference of the International Federation of Operations Research Society, IFORS, the 30th European Conference on Operations Research, EURA, as well as seminars of St. Petersburg University, Moscow University, Institute of Applied Mathematical Research of the Karelian Scientific Center, the Russian Academy of Sciences, Institute of Management Problems of the Russian Academy of Sciences, Chinese Academy of Sciences, Gerard Research Center, Qingdao University, etc. Research that formed the basis of the thesis were carried out with the support of grants from the Russian Science Foundation, the Russian Foundation for Fundamental Research, St. Petersburg University, Shandong Province Project, China, as well as the financial support of Gerard Research Center, Canada, and the Chinese Academy of Sciences as part of the scholarship program for prominent young scientists. Thank you. Thank you, Artem Aleksandrovich. Dear Council member, now you have the opportunity to ask questions about the presentation. If you have no questions, we will proceed to the next step. Then let us start presenting the reviews. Let me inform you that we received no external reviews, so I'm going to give the floor to the Council members. Since all the reviews have been published at the university website, I suggest you focus on the key points. If council members have no objections, then let us start with a review by Garnaev Andrei Yurievich, Doctor of Physics and Mathematics, Rutgers University, United States of America. Andrei Yurievich, you have the floor. Dear Chairman, thank you for giving the floor for the opportunity to present my review of Artem Sedakov. This is a great honor, and I have known Artem Aleksandrovich for many years. I have been watching his work. Last year, I heard his brilliant presentation at the conference, and it's so good that he's working, he's hard implementing the ideas of his academic advisor on cooperative games, and my review is positive, and it has been published at university website. The contents, and I outline the achievements, and then I've given some critical remarks, and my critical remarks are not about mathematics. I don't have any remarks concerning mathematics, but I have some remarks concerning the presentation. These are very of editorial nature. When writing papers in mathematics, the structure of the thesis is very good, and the idea is very well organized, starts with each chapter. There is a general idea, but it's good that each chapter starts with a literature overview, summary of the chapter, and then the chapter itself, and then obtained results. So it's important, shows the importance of results and the contribution of. So there is important. There are many works. So it would be ideal to would be this standard practice, not only to give a general literature overview, but to underline works as the most important works as a subsection, put them in a subsection, so that it will be clear to the reader where the roots of this work come from. And regarding these works, what is new? What's new in comparison with these works? Next is when talking about when you talk about applications, it's very good that in the end of each chapter there is a section on applications. For example, when you talk about management, will be in mathematical terms in the sphere of applications. This is given for the particular sphere of knowledge, not in terms of game theory, but in terms of this sphere, this science. So when there are many works, so some comparisons and graphs are important. These can be illustrations or real applications. What was and the graphs that graphs comparing your solutions with the traditional solutions. These are my general comments, but overall conclusion is that the work is very interesting and the author deserves awarding the degree, the desired degree. Andrei Yurevich, thank you for your review. Artem Aleksandrovich, you have the floor to answer the remarks. Thank you, Andrei Yurevich, for your remarks. I understood from your review that you said that the results of other authors not very clearly summarized and how they relate to what I have achieved. Here I agree. Maybe I should have better defined and demonstrated my contribution, but at the same time what I want to say is that in the introduction I have listed relevant works by other authors of the studied topic, and the results I have summarized in the conclusion of each chapter. Also, you spoke about the applied models and of cooperative dynamic games used in such problems such as harmful emission so the novelty of my results is in identifying conditions for time consistency of the core and IDP from the core, which has not been performed earlier. And it's true that I have some typos and mistakes, and I would be surprised if I had none. Andrei Yurovich, are you satisfied with the answers? Yes. Is time consistent? Core is a mathematical term. Is for economists. For an economist, that will be complicated, and so they don't know what the core is. So this is just to let you know. For a non-expert, that will be misleading. Okay, thank you. Now, one of the council members asked us to take a technical break. Is it necessary? Okay, let us take a technical break for 5 minutes. breaks every 30 minutes. So please come back after 30 minutes, after a technical break, and keep your camera switched on. If it is not necessary, if there is no if that is not necessary, we may continue. Okay. So we may take technical breaks upon request. Now I will give the floor to Malafeev Oleg Alexeyevich for his review, Doctor of Physics and Mathematics Professor of Department of Modeling of Social Economic Systems at St. Petersburg University. Oleg Alexeyevich, the floor is yours. I will try to give you a summary, and I will start with critical remarks. I have several comments. In chapter 3, says the central element says in the confidence of one player to the other, but the author never explains the practical analysis of this. Here I have to say that this is on the works the author based his results. Also, the style of the thesis is a little vague. Theorems 1, 1, 1, 4 is strong time consistency of the core as the non-emptiness of the core at each stage T of cooperative behavior. At the same time, assumption of non-emptiness of the cores has been earlier described in section 1.3 on page 38. Then I would like to say that the work has some typos and grammar mistakes, which are relatively few. These are relatively few, and as there's something that could be expected. Another critical remark, then studying time consistency of the core in section 114 because they can produce efficient mechanisms at that the relation between the initial characteristics in the reviewed of stochastic is not clear. So that will be interesting to discuss this. But in general, these remarks do not have no impact on the theoretical and practical significance of the work, which makes a big contribution in the contemporary game theory with multiple players. And the thesis by Sedakov, Artem, Aleksandrovich corresponds to the main requirements of awarding academic degrees at St. Petersburg University, and the degree applicant deserves to be awarded the degree of Doctor of Physics and Mathematics, Specialty 010109. Article 11 of above-mentioned procedure has not been violated by the author. So this is I've given my opinion. I am done. Thank you. Thank you, Oleg Alexeyevich. Artem Aleksandrovich, you may answer. Oleg Alexeyevich, thank you. As for your first comment, as you said, indeed, the theorems, this information is missing. The non-emptiness was mentioned earlier on page 38, and that was a natural assumption, which so non-emptiness means the non-emptiness of the core at each step means the players can use their chosen solution at each step. As for typos, I certainly agree with you, and in the most unexpected places they occur. And now you had one more comment about the comparison of the characteristic function of modified function. Yes, indeed, in my thesis I never mentioned that, but this relation was studied recently and published in Mathematics journal, co-authored with Sin Hao, and here also of common imputations of cooperative games. Thank you. Oleg Aleksandrovich, I'm satisfied with the answers to my remarks. Thank you. Now, let us give the floor to Mazalov Vladimir Viktorovich, Professor, Director of the Institute of Applied Mathematical Research, Karelian Scientific Center of Russian Academy of Sciences. Welcome. Dear Chairman, dear colleagues, I have known Artem Aleksandrovich for a long time. I've followed his work. He is a mature mathematician, and the work we are discussing today is original, is a big contribution to the game theory and network games. The very title, Dynamic Network Games, is original. Network games are very important. This is a contemporary study. Network games include social networks, transport problems. So we live in the world of networks where all things are connected. So today this is hot. This is a hot topic, and dynamic network games. This is even even more complicated when networks change over the time, as is the case with social networks. So the thesis is highly relevant. The work is written on a good level. Of course, there are some brilliant parts which I enjoyed very much. Let me mention them briefly. Modification of the characteristic function in the chapter 1, which guarantees that payoffs will not be negative at each step. This is it was very interesting. Next, game with a shock. It was very interesting. I liked very much the results connected with dynamic models, connected with achieving consensus. The results, obtained results, are non-trivial. For example, in chapter 1, what is connected with consistency of the core is a set, which is a set, and normally people working on this, they use shapely values, point solutions. So here a set is used, and to guarantee consistency, this is non-trivial to obtain sufficient conditions for that. The author demonstrates full set of tools in cooperative game theory, Shapley value, Marson value, AT solutions. So the work is very interesting, and I enjoyed it very much. And of course, I have quite a number of remarks, which I will read maybe. First, the title of the work is too general. Dynamic network game did only chapter 2 and chapter 4 are dedicated. Lots of attention is given to cooperative network games and procedures of imputation distribution. And second, in section 1.1 of chapter 1, there's a definition of dynamic network game which is not used. The game appears in chapter 2. It would make more sense to give this definition in chapter 2. As for today, the presentation was actually better than the presentation in the thesis. Chapter 1 gives a definition of network game, and then never mentions it. And then so chapter 1, which is very interesting, but to network games, it is not connected at all. The mathematical results are very interesting, but then it would be better to start with own proper dynamic network game. So there is some discrepancy. You expect to read about a dynamic network game, but it only comes in chapter 2. 3. The most appropriate title of the work is the second chapter. It can be formalized as a dynamic network game. The first step, players form links with each other and then can break them. Although in reality players can break off, they can also form new links. This limits the application of this approach. Although this restriction and conditions of the win functions, which simplify the type of characteristic functions, make it easier to study this game. So it's artificial situation. So the player at the top benefits from forming links. Fourth comment, in chapter 2, the definition 2.1 is inappropriate, which is repeated in 2.2 and 2.3, including index I and in the maximum. So it's in maximum and in the sum, so it's unclear. In section of the actions of payoff, players depends on environment and personally on who they are connected to. However, this specification is omitted later in the text. This should be said. 6. This is due to incorporation the players. So this economic tasks, and here is necessary to natural to negotiate. But procedure of distribution, and the graph of University Karate Club, which has a different meaning. The University Karate Club used for clustering, that's a different story altogether. Any graph could be used here. So there is no point in this graph. 7. In all models and cooperative solution, so sum of payoffs of all the players. This is a common situation which is not usually justified in specific tasks. This is profit minus costs, and even if the players play together. 8. The thesis never says about complexity of algorithm, obtaining equilibrium of multi-step network games, and distribution of imputation. There are some grammar mistakes, which are few. These critical remarks do not affect the overall positive opinion of the thesis. As a result, results obtained by Sedakov and Aleksandrovich are of significant contribution. The game theory obtained original results in this sphere, and the thesis on dynamic network games corresponds to the main requirements set by the Order 6882/1, the 1st of September 2016, on the order of awarding academic degrees at St. Petersburg University to doctor's degrees, and the author, Sedakov, deserves awarding the degree of Doctor of Physics and Mathematics, specialties 01010, Discrete Mathematics and Mathematical Cybernetics. Article 11 of the above-mentioned order has not been violated by the author. Thank you. Vladimir Viktorovich, thank you very much. Artem Aleksandrovich, please answer. As for the overall title, maybe indeed the title should be more. I should make more specific, make it more specific. But you see, in literature, network games usually include different types, not only models where players are nodes in a network, but also models where players managing object, for example, as is the case with social networks, where players attempt to manage elements of the network. And there is also the imputation distribution graph set by the graph connection graph. So in my opinion, this was the title includes all these aspects, but maybe there was a possibility to clarify this. There is a possibility. As for your comment, so as I first define network game and start talking about it in only chapter 2, yes, here I agree. I should have done it differently, but my idea is as follows. First, I wanted to demonstrate the object under study and use the results for give the results for more general class of class of games, subclass of which is dynamic network games, and then the results of chapter 1 are I use them later in the thesis. You had a remark that players may also add links. Indeed, this is true. It is possible to develop a theory taking into considering adding links, but also we can look at a situation where we need to solve a task to find network configuration and adjusting it for it to function. And here we may find that adding new links is not advisable because the network is functioning and we don't need to. It needs no interference. While removing links means failure of a particular element. But of course, the possibility can be considered. Different configurations can be considered as well. Of course, there was a comment on using the same index for various objects. That's a very unfortunate mistake. Because next you said that players' payoff depends on the environment and not only on their neighbors. And here everything is explained by a specific task, and in your context the tasks where forming new links is relevant. Here in this case, players play off depends on the immediate neighbors. For example, in the problem of analyzing social networks, opinion dynamics, it's not necessary to make this assumption. We may just assume that the payoff depends on the opinion of the agents, or like mean or aggregated opinion. Next, your next comment was about chapter 3, cooperative variant looks artificial, not negotiations not considered. Here I used this standard method used in game theory, where when building cooperative situations, an optimization task where the function is a sum of payoffs of all the players. Here I wanted to show that the choice of characteristic function was chosen because I not only because it was a cooperative task, but the overall solution can be non-cooperative behavior can be analyzed. But otherwise, of course, I'm sure this model also permits usability and usefulness where other solutions can be used, for example, some arbitration schemes. As for the Zachary graph, this was an illustration. We did not make any clustering, so we used two resident instructor. A resident, in a sense, is two players, two opinion who have may impact opinions. 30 out of 100 nods. They demonstrate with which objects we can work to obtain a solution. Next, you made an interesting comment about summing up the costs in a coalition. When players get into a coalition, the costs they can optimize the costs. Here again, if we use the classical traditional approach, where we use sum of all the players, then it completely corresponds to the standard procedure. So here there is an article, oligopoly games, is published in 2002 in Mathematical Social Sciences, and this article considers the task of an oligopoly competition, and it described two cases of oligopolic modeling oligopolic functions where firms use this technology when they get into a coalition, and the costs are, and sum up the costs. But generally speaking, what I have presented to you today can be carefully applied to cases where the coalition costs are optimized. And in my thesis, I did not describe the complexity of an algorithm because this was not my goal. So I cannot evaluate. And yes, there are some typos. I'm sorry about that. Thank you. Vladimir Viktorovich, are you satisfied with the answers? Dear members of the Dissertation Council, do we need to take a technical break or can we continue? Please nod if we need to continue. Then let me give the floor to Vasin Alexander Alexeyevich, Doctor of Physics and Mathematics, Professor of the Department of Study of Operations of Moscow University, named after Lomonosov. Alexander Alexeyevich, the floor is yours. Dear colleagues, I have a positive opinion of this thesis. In my review, I mentioned the advantages, the tasks, the interest and points which deserve special attention. Many of these tasks are already been mentioned, for example, by Vladimir Viktorovich Mazalov in his speech. So what I would like to do once again is that the author has analyzed a wide range of dynamic games, network games, and it is of theoretical and practical interest, and obtained original results regarding the conditions of time-consistent solutions. This, to me, seems very useful to me. As for drawbacks of the thesis, let I mention the following in my review. The literature review reflects good knowledge of foreign sources. At the same time, it doesn't reflect some important works by national scientists. As for the model of opinion dynamics, this is an article by Krasnoshokov, which is directly connected with models analyzed by the author, and in comparing the results obtained by the author with results obtained by Pavel Sergeyevich would be very useful and productive. The second omission, in my opinion, is a question of in the works of my works together with Vladimir Alexandrovich Gurevich, and published back in 1977, and later we published with Borash. Gurevich already worked at Rutgers. We published two joint works on the condition of existence of the core in cases when set of coalitions is limited. The conditions connected with the so-called consistent collision sets, at which limitations on sets the core and some of our results are connected to the game graph, which gets so much attention from the author. And if he considered our results, it would be possible to make a fairly general theorem of existence of time-consistent graphs. As for the other critical remarks, sometimes in addition to grammar mistakes, there are some phrases are hard to understand. I shall not read them now. Of pages 268, I quoted, and it seems useful for everybody, for all the researchers, young researchers, not to write very long sentences. This helps to make the text more clear. And my third comment is in line with what was mentioned by Dr. Garnaev. The author limits himself with technical results and examples. He mentions practically significant topics such as harmful emission, stopping harmful emission, but uses them only as illustrations, and it would be at least sometimes to see these results put into practice and practical application. Such conclusions that can be discussed from the point of their applicability. But these drawbacks do not affect the high opinion of the thesis. The author time-consistent solutions and the description of time-consistent imputation distribution procedure for various types of cooperative network games has great practical significance and make contribution in the development of cooperative game theory. The thesis by Artem Aleksandrovich Sedakov corresponds to the requirements set at St. Petersburg University on awarding doctor's degree, and the author deserves awarding the degree of Doctor of Physics in Mathematics, Specialty 010109. That's all I had to say. Alexander Alexeyevich, thank you for your review. Artem Aleksandrovich, I agree with your comments. The literature review, the results, the sources that you mentioned, of course, are highly relevant, and I'm sorry I missed them. I read them only after I read your review. Pavel Sergeyevich's model I should have discussed, compared with our models. He also used a special matrix, impact matrix, so we could analyze what the two models have in common. The second part about existence of the core in the game family with limited collisions. Here I would like to say that here we don't mean that collisions cannot be created. Any collision can be created, but when considering cooperation, all the players get into one large collision, and the whole construction connected with the characteristic function is necessary. Only the total payoff of the players. It's necessary to understand how much each coalition can win. And at the same time, the main accent is we place on time consistency. This property of the solution, such imputation distribution rule is observed at each step, at each stage. So we want this solution, a cooperative solution, to have quality. So the players were not interested in reviewing it in process. So what they agreed on initially, we want this to be implemented, and these instruments proposed, the typos and complex phrases I have in my thesis, I absolutely agree. And about the results of existence of the core in the game family, we should have analyzed how so you have a result for condition special on graph, what set of coalitions is needed for the core to exist for a given set when players in a network. So we could have studied this. And the policy, as for policy implications, so the main conclusion I can make is that players, when choosing a cooperative solution, should take into consideration its time consistency. In my work, I showed that in two-step network games, the simplest solutions are not time consistent, and the players have to consider the possibility of breaking the agreement and take some actions to maintain it. And the mechanism based on imputation distribution procedure proposed is next. What else can I say? Having a solution, each player will know his strategy and what strategies will be pursued by his opponents, and these solutions become they can define individually. They will understand how these solutions will change if the initial parameters are changed, input parameters. Also, the players may know, when they know the solutions, they know what resources they need if it is necessary to implement the given strategy. Also, I'd like to say that when analyzing applied solutions, applications in managing harmful emissions, 541, there is one point I demonstrate that increasing the number of players leads to higher cost of anarchy. There is less balance between, so that which is very natural, but at the same time this fact requires more effort for coordination of the players if they choose to cooperate. Thank you. Alexander Alexeyevich, are you satisfied with the answers? In general, yes, but I would like to draw your attention the peculiarity when it's advisable to see policy implications. They should be expressed in a language which is clear not only to game theory specialists but to the people working in these industries. And so this is maybe you have not come across such problems yet, but of course these comments do not diminish the significance of the thesis. Is just a suggestion on how it could be developed in the future and future but otherwise I'm fully satisfied. Shall we continue, or do we need to take a technical break? Let's take a technical break for 5 minutes. for inviting me to participate in this interesting jury. If you don't mind, I shall give you a summary in English because I wrote my review in English, and so for Professor Lee it will be easier. If you have any objections, no, we have no objections to that. The chairman, here we have the technical support is asking you to speak in Russian. Thank you. Okay, I will continue in Russian. Maybe my Russian can be not very good. Let me start with the overall review of the thesis. The thesis deserves respect. I'm very impressed by the number of results, of covered, solved tasks, and the number of technical solutions and methods used by the author of the thesis. The thesis consists of 5 chapters. I liked personally chapter 1, where the author gives a fundamental I agree and disagree at the same time with Professor Mazalov. I feel that there is some need, some disagreement. First, the term is introduced very well, and then suddenly the author starts talking about the general dynamic games, and then we go back to two-step games, and that is a particular case of a general solution. So maybe then the name of the thesis should be different, such as dynamic games with application to dynamic networking games, or maybe start with use the induction approach, talk about two-step games, and then generalize it, proceed to the more general situation. On the other hand, a simple solution to drop chapter 1, so that would be a bad solution, because very interesting, brilliant results were obtained, and even if this chapter does not agree with the nature, with the main theme of the thesis, it still makes an important contribution of the applicant to the general theory of dynamic games. So I really liked chapter 1 because it presented some new solutions. Then I liked chapter 3, but consensus and games in social networks. I work a lot on modeling social networks. Maybe that is why this chapter is very close to my own research. I will start asking questions on the way, and my first question is of specific nature. I have a question about figure 318. Let me check. Yes, figure 318, 317. As I understand, this is an example. One of the players has a goal to achieve opinion, the value 0.6, and and the other player has the goal to achieve opinion 0.4, while the scale on both figures only reaches up to 0.35 or 36, if I'm not mistaken. So maybe this is a typo, or the opinion, the resulting opinion does not exceed 0.35. I don't understand as a cooperative solution. I wouldn't take part in such a game. So the first player is a complete loser. He had 0.6 and he agreed to something about which the second player was not even dreaming. So this is like a competition between political parties, right and left wing parties, and with extreme right party. In a political situation, that would be it's just not possible. So maybe this is a typo, or maybe there is some logical explanation to this. Next, I liked chapter on games on tree. In here a question, can it be developed in the case of unlimited time, and what can the results be which results can be easily developed and which not? And maybe my last question is, after reading the thesis, I have something was missing. Everybody noticed that observed that this is a new sphere with significant theoretical contribution, with new models, and I was looking for what can be further developed in this sphere, and maybe I missed something, but I never found an overview of future research or an overview of interesting points for discussion or future plans. It will be interesting to learn which future development which developments the work may have in the future, and which tasks the author tried to address but could not. But as I said already in the beginning, the work is very wide. It's very wide scope with different methods and new task setting. The quality is mostly very high, and the author certainly deserves awarding the degree of Doctor of Physics and Mathematics. That is all. Thank you, Konstantin Evgenievich, for your review. Artem Aleksandrovich, Konstantin Evgenievich, thank you. As for figure, the situation is as follows. Indeed, the maximal possible value is 0.35, but here it is necessary maybe to consider some circumstances. The first circumstance is the number of steps. Maybe the number of steps is insufficient. I think it is 15. In 15 steps to bring the opinion of the entire network to the desired result. So that's one thing. Second, here we assume that the player payoff depends not only on the opinion of the society, but also on the resources the player uses in the influence model, and maybe it may happen that the resources it's very resource consuming, and to minimize the costs, it's better for the so they seem to be comparable. First I thought about that, if they were different by 10 times. Yes, you see here, it's difficult. It's hard to comment the reason for this, I see the explanation to be the following. Maybe the resources, the additional resources the players have chosen for influence, maybe these resources are insufficient, or still insufficient to lead the opinion to the desired opinion. But on the other hand, maybe in the target function, those costs as influence and opinion, to give them different value. For example, if the opinion of the society is more important than the costs of the player, then maybe the results would be different. So maybe the opinion will be closer to the desired. So this is an interesting result. The result is really surprising. Second, you asked about games with unlimited number of steps. This is a complication and a simplification at the same time, because usually complication is usually connected if the player's strategy depends on the time, then that will be that will be an additional challenge to find a solution in the game. If we talk about stationary strategies here, it doesn't matter to the player. He just watches the status, the stage, and maybe it will be easier to find a solution, because function becomes does not depend on the time factor, depends only on the status, and in that case it may seem to be a simplification. And your third remark about future research, indeed I have not described what could be done, but what I can say is that, for example, it is possible to include other mechanisms for creating or deleting links with random influences. One player, several players can be excluded. Also, it is possible to analyze efficiency of proposed methods and evaluate their complexity. I had no space for that, to describe that. Also, we can analyze application of dynamic network games on the using the statistical data, not using parameters such as costs, but using the real statistical data to evaluate these parameters in a model. Or next, it's possible not to limit oneself with cooperative solutions, the core and the shapely value, but we can go a little further with non-transferable usefulness as other solutions, such as the arbitrary schemes, use various new forms of opinion dynamics in social networks. They are many. We don't have to, the growth of Friedkin-Jones models, we don't have to limit ourselves. We can use other models, for example, with changing coefficients, with changing trust. Also, what I would like to say, in addition to what I have included in my thesis, we studied the common imputation of cooperative dynamic games and impact of negative payoffs. In the thesis, we demonstrated convergence of this process in non-negative payoffs. So we deviated from this assumption and published the results in 2020 in Mathematics, co-authored with Nikau, and in comparative network model of environment protection nature. This work I co-authored with Han Xian, and it will be published in European Journal of Research. So that's what these are my answers. Konstantin Evgenovich, are you satisfied with the answers? Yes, I am. Thank you. Thank you. Now I'll give the floor to Dr. Li Denfen, Doctor of PhD, China.
I think the process is very good. Just as in my comments, I mean this work is very important, and all the general, in general, the research is original, so it is very useful to the in the theory and the political. But I one question, just as in my comments, in the subsection 4.3, the theory study the correlation gains with the interval payoff. In this session, the paper give one solution that is the interval supply value like, and study the time consistency. But in the interval supply value like, it will use the interval subtraction. This interval subtraction is the most interval operation. This interval subtraction will use the is innovable. So the result will result to unreasonable. So my question is, what kind correlation gains this method can applicable, or what kind situation in the management science management situation? How to improve this correlation gains? Use other interval operation. That's my question.
Заслушаем полностью отзыв, потом ответ на все вопросы.
Let us hear the entire review, and then Professor Lee, please continue your speech, and Artem Aleksandrovich will answer your questions in the end, after you finish speaking. Or is this the end? You have to... Мой вопрос заключается... Да, как использовать интервал? Could you please finish your... the question, he understands the question. You have to finish your review, please. Could you please finish the review? Say if the author deserves or does not deserve the degree. As far as I could understand what what type of cooperation. Here, cooperation is used in the same sense that the players choose an action together. The only difference is that the players' payoff is not is by closed interval. So this is the main difference. Are you, Dr. Lee, are you satisfied with the answer? Dr. Lee, are you? So please say if the answer was okay or not okay. Are you satisfied with the answer?
I think that
do you have other questions or critical remarks?
В отзыве они отражены, по крайней мере, нет?
no. Yeah, okay.
Хорошо.
Very well. Could you please say the author deserves to be awarded the degree? Please finish. Your review, you asked some other questions, so maybe Artem Aleksandrovich should answer all your questions. So your first comment was about Theorem 112 on page 372, and here Professor Lee proposed to work with formal vectors, using vectors of yes. A second comment was about typos. Yes, indeed, there are, you've mentioned exactly sentences index T instead of 0, 11 instead of 9, so it's B. So these are typos. They have no impact on the results. A third comment is about some repetition. There were repetitions. For example, you repeated the definition of imputation on pages 345 and 413 of the English text. Indeed, there is a repetition. What I wanted to say in the second case, when I given the imputation in two-step network games, I do this to demonstrate the dependence of the characteristic function of V2 on the formed network. And the final comment was on Moore operation, and here you asked, this operation is irreversible, and maybe other solutions should be used, other ways of deduction should be used. And here I just wanted to say that in the work, when construction of time-consistent analog of Shapley value, they use the solution based on the Moore's difference operator, and this solution is called the Shapley-like value. And in the literature for cooperative interval games, the interval Shapley value is determined by this solution for so-called monotonic games, and not defined for free cooperative interval games, while the solution used in the work it can be used for any game. Thank you, Artem Aleksandrovich. Professor Lee, please say again, are you satisfied with the answers of the applicant? Professor,
Хорошо, спасибо.
that's very well, thank you. And so finally, I have to give my opinion and present my review. And I must say that I'm working in a neighboring sphere of differential games, and I'm studying similar tasks. So I had the opportunity to study the results obtained by Artem Aleksandrovich in detail and test them for validity. The previous speakers have already outlined the contents of the thesis, and I will just remind you that the chapter consists of 5 chapters. The first chapter of a general nature is dedicated to dynamic games, cooperative dynamic games, and it proves a number of theoretical results. Most of all, I was interested in Theorem 112 and behavior of the characteristic function. Some of the results obtained in Chapter 1 were clarified for a wide, broad class of games, dynamic games, class of network games. And chapters 3, 4, and 5 were dedicated to the study of a narrow class of tasks. Chapter 3 was dedicated to the study of impact on the opinion, dynamic network games with full, perfect information on 3 graphs. And in Chapter 5, the author explored other types of game. Among the strong points, I would mention its relevance, the relevance of the theme. As we understand, network structures in conflict situations today occurs everywhere in different tasks, in communications, in transport networks, social networks, in economic activities of various firms. And in addition to that, I should say that I want to believe that our society is developing towards cooperation of the participants, not towards confrontation. And we may assume that potential significance of this research will increase over the time, and the results obtained by the author will be in demand for cooperative solutions in various network games. The theoretical significance, in my opinion, first of all, is explained by the contribution into the theory of network games, multiple step network games, multiple step network games with a shot in cooperative settings. The author obtained a number of interesting theoretical results for dynamic games. And the novelty, scientific novelty, is proven by the interest from highly rated journals where Artem Aleksandrovich articles were published, including articles on game theory, networks, operations, study of operations, and the results were tested in Russian and international arena. Credibility of results, the strict mathematical evidence, because the main statements are given as theorems and statements, which demonstrates high level of skill of the author. Yet I have made a number of critical comments. Let me proceed to these. Some are insignificant and they are about definitions, but some critical remarks are more significant. First, the consistency of the chapters is not sufficiently convincing. It is obvious that all the chapters except chapter 5 deal with games with network structures, and some are quite narrow and specific. This is chapter 3 and chapter 4, but the fundamental results obtained in chapters 1 and 2 are not used, or practically not used, in chapters 3-5. Although, in the end of chapter 3, an example mentions the conditions of strong dynamic stability of the core. In chapter 5, quite interesting results were obtained on the study of such an indicator of importance as the price of anarchy. In addition, the price is calculated in chapter 3, but these results are not generalized or analyzed for a more general case in the remaining other chapters. 3. The results of chapter 3 have no practical significance. Maybe it should be considered in the context of simulation task. They considered influence matrices to satisfy all the properties, transition matrices in Markov chains, but they developed theory, such as check-in matrices for reducibility, acyclicity, were not used. 3. Chapter 3, page 188, the first phrase, we will say that consensus is achieved if there is a vector, etc., is not a definition, but a statement to be proved. The definition is given in the previous sentence on page 187. 4. Chapter 3, Theorem 3.2 follows from Theorem 3.1. 5. Chapter 1, definition 1.1. It's not clear whether the graph is considered without loops or not, but then, in some problems, loops appear. Chapter 6, Chapter 1, page 25, etc. Notation, the difference, there's a typo, and it was corrected in the presentation as I said. 7. Chapter 1, definition 1.5. Here the symbol is incorrect. The two sets. 8. Chapter 1, Theorem 1.12. The proof is incomplete. Theta eta is not taken into account. Chapter 2, 6 of non-negative Ashita momentarily pay off. How this narrows the class of tasks analyzed. This is a question. And 10, chapter 2, page 55, shock refers to loss of connection with the player. How much rework does the structure theory requires when the shock can be understood as an acquisition of additional connections with player? And it should be mentioned that these remarks do not affect the overall positive impression of the thesis. The work by Artem Aleksandrovich Sedakov is written on a high scientific level and makes a significant contribution to construction of the modern game theory. The main contribution, in my opinion, is dynamic network games and developing tools for cooperative solutions for the above class of games. I think they deserve the thesis by Artem Sedakov on the theme dynamic network corresponds to the basic requirements set by the at St. Petersburg University by the order and awarding academic degrees, and the degree applicant deserves awarding the degree of Doctor of Physics and Mathematics, Specialty 010109. Artem Aleksandrovich, you may answer. Ekaterina Viktorovna, thank you. Your first comment on lack of agreement between chapters in the network games. Network games include different types of tasks, and for their solution different methods can be used. So maybe in some sense this disagreement of the method leads to this opinion, but all the considered tasks remain within the framework of network games. And in chapter 3 the characteristic function is constructed, which allows us to use the results of chapter 1 on this dynamic, on the consistent formulation of some characteristic functions. The results are not specifically duplicated in chapter 3 because the first reason is not to repeat them, and second reason, in chapter 3 we look at a special model of linear game, and in it is not always possible to show analytically of a non-empty core, and this part was so we did this work only where we performed actual modeling. Choice of search for price of anarchy we performed discussed in chapter 5, analyzed for sensitivity, and here they are very search for the price of anarchy it's very complex. It's not easy to identify each in a real form. For some tasks, only the upper limits have been defined. In chapter 5, the game structure allows to measure the price of anarchy in real form in the context of players pay off Nash equilibrium, so we can measure the price of anarchy. For example, in chapter 3 it is impossible to achieve because players pay offs or depend on strategies, trajectories from recurrent relations. Such analytics is quite complex here. As for your second comment, there's a large number of graphs in chapter 3. The material is given as an illustration of application of dynamic network games. In this chapter, the opinion and solution was found in class of a large number of graphs and tables, because I demonstrated many objects, strategies, equilibrium in different classes, initial opinions of agents, final opinions of the agents in different models. And because of such comparative analysis, it seems that in this part we have too many graphs and too many tables than in other parts of the thesis. Artem Aleksandrovich, we have to take a technical break. One of the council members is left this session. We'll take a technical break for 5 minutes.
Олег Алексеевич, вы здесь, да? Ну все, давайте продолжим.
We are back, and let us resume the session. Artem Aleksandrovich will continue answering my questions. So, where consensus is reached when there is a value, as components do not depend on the matrix, the structure, so the lines of the matrix. And then next we prove that it is possible to reach consensus for W matrices. So in cases when we can guarantee that consensus can be reached, the final opinion is defined as a product of the opinion of the agents. Your comment 4 is how theorems 3.1 and 3.2. These are both theorems are well-known results in the theory of Markov chains, and they are presented in the thesis as formulated in different sources. And in the context of the model under our study, it was not so important whether one result is a consequence of the other or no. So I used both results. 5. In the definition 1.1 is we accept loops. So in the part where we look at in chapter 2, we assumed that a player cannot graphs without loops, and a player cannot establish a link with himself. And opinion of an agent. An agent may have his own opinion and relate to it. Comments 6 and 7 I accept. I have made some corrections as an element of a set, and the symbol I used function maps to maybe use the function differently. Comment 8, in incomplete proof of theorem 112 is indeed the proof is incomplete. The matrix theta can be represented in a special form, and when this matrix has own values, and the equation on just means that matrix can have its own values bigger than 1, and this this formal proof, I will work on this formal proof in nearest future. I conducted a number of experiments when this matrix has similar numbers, and these tests prove that the results remain the same. So I just have to demonstrate this formally. And as for non-negativity of payoff, here it is possible to on this problem from two sides. First, it doesn't narrow the class of tasks. First, we may assume that each player is given a sufficient number of resources, which makes the function always non-negative. Each player is given equal share of resources. And second, on the other hand, of course, the very fact of negativity of the function in application is possible. There are applications where a player's payoff can be at a particular step can be negative. And what I wanted to say, in addition to that, in Sun Hao's work published in Mathematics 2020, this case has already been analyzed. It demonstrates what additional requirements conditions are necessary to ensure convergence, and the final comment was on the complexity of processing results of the theory when shock means acquiring additional links, connections. Here, in my opinion, this assumption does not require significant transformation, serious transformation. What we have to do is consider the effect in the function of player payoff. The cooperative strategy will be similar to the structure I have analyzed in my thesis. Players will choose one network until a shock occurs, and after the shock occurs, they may transform the network and stick to it. But this is my assumption, which I must test and describe formally. But I think there will be no qualitative difference in results. And the results on types of characteristic functions, Shapley's value, and the imputation procedure. These results are described in terms of characteristic functions. Once we know characteristic functions, we can measure Shapley vector, and then IDP. Your question about adding links is on the border of where to construct the characteristic function. After that, the results will remain the same. Thank you. It's very nice that some of my comments you have already included in papers published today, and the other part hopefully will be included in your works next year. Now, have we received any questions online? No, we have not. That's fine. And now we can give the floor to is anyone willing to speak? Any of the attendees, any of the listeners? No one is willing to speak. Very well, then let us give the floor to the academic advisor, Leon Agnesovich Peterson, professor of St. Petersburg University, Department of Mathematical Theory of Games and Statistical Solutions. Dear friends, I wrote a review. You must have read it. What I wanted to say is something specific about this class of games. What makes them different from dynamic games? Let's look at a simple case. Only 2 steps. In step 1, players create connections between themselves. Each player can find himself a partner from a set of partners. For example, I cannot find myself a partner from Aborigines in Australia. It's also important that each partner may have a limited number of other partners. It's impossible to have 9 billion partners. So these limitations have never been, we never had them in defining network games. So that's an interesting new word in the definition of a network game. So what we found is that in step 1, a network is created with a number of limitations. In step 2, players start interacting, start playing. They interact in a sense. They have different interests and game situations. Even the simple simultaneous game, and it occurs that even in this case, the initial agreements made before the network was created, the imputation distribution agreement, for example, 2 steps are not observed. They are not supported. After 1 step later, it seems players may leave the agreement. We see that in real life very often when states agree on some alliance, and then 1 year later this alliance falls. So this is not because politicians are bad This is in the essence of human cooperation and company cooperation, and to overcome this we need this procedure of distribution, some mechanism that would give the opportunity to overcome this problem. So this mechanism was proposed by the author. This is a specific feature of this class of tasks, and on the easiest, simplest example, as for the author, he turned it into more complicated networks, but the essence is here, and this is specific to this class of networks. And second thing I wanted to say, I'm very happy that ideas of dynamic sustainability, which started back in 1977, I observed that nothing is stable. No agreements can be observed for a long time, is the case here. And the mechanism of preserving cooperation, which I proposed in 1979, this imputation distribution procedure came useful, and which is very pleasant for me. I think the work definitely deserves positive assessment, and I wanted to say some words about Artem Aleksandrovich. I have the right to do so, as you understand. Hope you agree. He works he's very active, not only as scientist, but he's involved in many joint projects, in many grants. He was, maybe not last year, he was busy with his thesis, but like for 10 years or 11 years, he was an active organizer of an international symposium on game theory management, which is well known around the world. 7 Nobel Prize winners, 6 Nobel Prize winners came here. This is his achievement. The author has also contributed to that. I wouldn't be able to do this alone. So this part I also would like to emphasize. Artem is always willing to cooperate, and everything he does is of high quality. That's all I wanted to say. Thank you, Leona Ganesevich. Do we have any questions to the academic advisor? Now I have to ask if council members, other listeners, or the degree applicant do you have any unanswered questions since our regarding the procedure? If there are no questions, then now we have the opportunity to take a 5-minute, is not a break. No. Now before we vote, we may have a private discussion if we need this. If we don't need this private discussion, we may proceed straight to voting. What do you think? Do we need a private discussion? Okay, let us then ask, please stop online broadcasting. Dear colleagues, dear attendees, our session is resumed. Please resume broadcasting. I put the question of awarding to Sedakov to the degree of Doctor of Physics and Mathematics, Specialty 010109, Discrete Mathematics and Mathematical Cybernetics, to open individual vote. Let me remind you that a decision of the Decision Council shall be considered positive if more than a half, but not less than 3 members of the Council present at the session vote for it in accordance with Article 23 of the Order. Malafeev Oleg Alexeyevich, your opinion? My opinion, I have already given. I support awarding the degree. Thank you. Vasin Alexander Alexeyevich, I am for awarding the degree. I support this decision. Mazalov Vladimir Viktorovich, I support awarding the degree. Avrachenkov Konstantin Evgenievich, I am for awarding the degree. Doctor of Science. Garnaev Andrei Yurievich, I am for awarding the degree. Professor Lee, yes, and me, Chairman Gromova Ekaterina Viktorovna, support awarding the degree, Doctor of Physics and Mathematics. Thus, dear colleagues and guests, let me inform you that out of 7 members of the Decision Council present, 7 voted for, no one voted against, and no one abstained. The decision to award to Sedakov Artem Aleksandrovich the degree of Doctor of Physics and Mathematics, Specialty 010109, Discrete Mathematics and Mathematical Cybernetics, has been made. Artem Aleksandrovich, we congratulate you. Dear colleagues, since our session it was held in the remote access mode, do you have any, maybe Decision Council members or degree applicant or others present have any comments or questions regarding the procedure of our session? No. Then let's give the floor to Artem Aleksandrovich for his closing remarks. Dear Dissertation Council members, thank you very much for reading my thesis, for your reviews, and for the positive feedback. I understood that there's a lot, I still have a lot to work on. The theme has not been exhausted. There are some open questions, open issues that need to be explored. I am very grateful to you. In such dynamic circumstances, you were able to attend, and without any major technical issues in the online mode. Thank you very much. I also want to thank Leon Aganesevich for showing to me what science really is for this theme, as council members said, which is very relevant and important, and it's very rewarding to work on relevant and important tasks. And I'm very grateful to you for your advice, for your support, and for everything, all the accompanying questions. Working with you was a pleasure, and I'm very grateful to the department for their support. Lena, thank you very much. Your comments are always so accurate and so much to the point. Larissa Viktorovna, thank you for all the taking care of all the organizational issues. I hope that means from the technical point it went very smoothly. Thank you very much, everybody. I declare the session closed. Thank you, everybody, for participating.